dark in here. Energy. The Energy Information Administration estimated that in 2020, the United States itself used 93 quadrillion British thermal units of energy. That's 2.7 times 10 to the 16 kilowatts of energy just in 2020 alone. An overwhelming 79% of our energy production comes from fossil fuels. That is, natural gas, petroleum, and coal. Scientists and environmentalists around the world have agreed that this type of energy production is not sustainable, citing irreversible damage to the environment. But of course, how do you fix that? The suggested course of action is eventual replacement of fossil fuels with cleaner energies like nuclear and renewables. But the question begs to be asked, which is better? Here's a clip of me driving by the solar farm at the Oceana Naval Base on a nice clear day with the sun shining bright. Solar is only one type of renewable energy. There's others like wind, hydropower, and geothermal. However, not every day is a sunny day like this one, and not every day is a windy day. This is the downside of renewable energies, especially in wind and solar. This aspect of energy is called the capacity factor. The EIA defines capacity factor as the ratio of the electrical energy produced by a generating unit for the period of time considered to the electrical energy that could have been produced at continuous full power operation during the same period. The capacity factor for nuclear energy is 93%, while the capacity factors for renewable energies are 74.3% for geothermal, 41.5% for hydropower, 35.4% for wind, and 24.9% for solar. This means that nuclear is producing max power more than 93% of the time during the year while it's operating. Meanwhile, each renewable produces a fraction of this. Waste has become the largest consideration in investment into future energy technologies. Nuclear is advertised as a clean energy. It's true, nuclear produces no air pollution or greenhouse gases. In the pictures you see of cooling towers that are part of nuclear plants, there are clouds billowing out of the top. These clouds are actually just steam, released from water that cools the generators. It really is just water. As with all things, there's also downsides. Nuclear energy produces radioactive waste from the breakdown of uranium. If not properly stored or disposed of, the radiation can be deadly and destroy ecosystems, and cause defects in humans. Fortunately, there are already long-term solutions, such as storage facilities, being developed to properly dispose of spent fuels in a safe manner. If nuclear were to expand, however, governments and nuclear agencies will be forced to find new sites to store the increased amount of waste. Other environmental dangers include nuclear meltdowns, such as the ones in Chernobyl and Fukushima, which causes almost permanent damage in the area surrounding, as well as in nearby cities. Fortunately, the last nuclear disaster was 10 years ago in Fukushima, Japan. In response to Fukushima, the U.S. Regulatory Commission specifically has added multiple measures to prevent a similar situation. Of course, disaster is only as avoidable as the reactor design is thought out and the people operating machines are skilled. I haven't even mentioned the environmental impact of the mining of the fuels that are needed to actually produce the nuclear energy, such as uranium, thorium, and plutonium. In comparison, the only waste that renewable energies produce is from the sourcing and construction of their corresponding generators. Specifically, elements such as neodymium, dysprosium, cadmium, and other elements listed do not have methods of recycling yet. Additionally, the generators often have an impact on the ecosystem surrounding due to their geographic footprint. For example, wind turbines sometimes pose a danger to birds. Hydropower also poses the most visible change to an ecosystem, where an entire ecosystem reliant on a body of water that is used for the energy can be changed from the building and running of a dam, with fish and other aquatic animals often being killed in water turbines. Although it's difficult to compare costs of energy technologies, governments and private entities attempt to through the use of levelized cost of energy, or LCOE, as it's known in short. LCOE measures lifetime cost of energy sources compared to the power generation it produces over its lifetime. Take a look at this graphic compiled by Lazard, a private equity company. Notice how solar has multiple subcategories. Also note how, in a lot of these technologies, the range of LCOE varies by almost $100. This just shows how unpredictable and varying energy production can be. This Reuters article uses a figure similar to the LCOE, which is dollars per megawatt hour, from the World Nuclear Industry Status Report. As you can see, the ranges from 36 to 44 for solar and 29 to 56 for wind are much lower than 112 and 189 for nuclear. These numbers more or less track with the numbers posed by Lazard.
In conclusion, we don't just need nuclear or renewables to solve our energy crisis, but both, working at the same time. But on the topics we compare today, nuclear has a much larger capacity factor. Nuclear produces radioactive waste and also has an effect on the environment, just like renewables. However, with renewables, we only need to worry about the materials that are required to construct generators. And lastly, the cost. Of course, nuclear costs much more, but there are cases in which nuclear will be more efficient and more economic than a certain renewable energy.
As for bias, here's the list of sources I used in researching and making this video. Bias was a large factor in researching this topic. First, I had to identify my own opinions on the topic. I support both sides due to their ability to minimize environmental pollution, but I believe nuclear was the better and more realistic option. Keeping that in mind, I had to research both sides carefully, considering the attention I give to each. I tried to make it so that both sides receive equal attention in the area of discussion, such as capacity factor or waste. Additionally, I ensured the sources I took statistics and facts from were verifiable by other non-biased sources. But, of course, as a student, I am limited by time and resources. Do not put the same trust into my video as you would someone more qualified. So thank you for watching.